In this video, we will solve the 8th question from the first set of mechanical engineering question paper that was conducted in GATE 2019. The question is, during a non-flow thermodynamic process 1 to 2 executed by a perfect gas, the heat interaction is equal to the work interaction, that is Q1 to 2 equal to W1 to 2. When the process is option A isentropic, option B polytropic, option C isothermal, option D adiabatic. You can also refer to the NPTEL course Mechanical Engineering Basic Thermodynamics coordinated by IIT Kharagpur. Before moving to this video solution, let's see some basic useful data. We need to know first law of thermodynamics. For a process, the first law of thermodynamics is defined as delta Q1 to 2 equal to delta W1 to 2 plus delta U1 to 2, where delta Q1 to 2 is the heat interaction of the system to change from state 1 to 2. Delta W1 to 2 is the work interaction of the system to change from state 1 to 2. Delta U1 to 2 is the change in the internal energy to change the state from 1 to 2. Okay, I will be explaining about this concept more detailedly in the video solution. Here in the question is given a non-flow thermodynamic process, which means it is a closed system. As we said earlier, for a process 1 to 2, according to the first law of thermodynamics, we can say that delta Q1 to 2 equal to delta W1 to 2 plus delta U1 to 2. How did we get this? I'll explain with one simple example. Let us consider a closed system with a piston. This is the piston and there is a gas, a perfect gas. Okay, this is a closed system. Closed system means there is no flow of the gas from this system. Okay, this is our system and there is no flow of gas through the boundary. Hence, it is a closed, because it is a closed system. Now what we are doing is that we are supplying an heat. We are supplying some amount of energy. Because of this energy, what will happen? The temperature of the gas will increase. The pressure will increase. Because of this pressure, higher amount of pressure, the piston will go up because of the pressure. So after some, this is state 1. And it reaches a state 2 where the piston has moved from this position to this position. Now this is state 2. Here the piston has moved up. That we have given the amount of energy Q. And since the piston is moved up for a distance x, there is a work done. Who has done this work? The work is done by the gas, because gas is pushing this piston, and the temperature of this gas is also increased. So the work is done by the gas, means gas is doing some work W to change the system from 1 to 2, and also the temperature of the gas is increased from temperature T1 to T2, and for that the internal energy of the gas is also increased for system U1 to 2. Okay, but how did this gas get this both energy? This both energy, they got it from Q1 to 2, in which we are representing it as a delta Q, delta W, delta U. So this is how we got the first law of thermodynamics. According to the question, it is said that delta Q1 to 2 equal to W1 to 2. If this is given, according to the first law of thermodynamics, we can say that U1 to 2 is 0. That means the internal energy change is 0. Internal energy change is 0, which means what? In state 1 and in state 2, the internal energy is same. And what is the change in internal energy? Formula is M, where is M is the mass, CV. CV is the specific heated constant volume, and delta T is the temperature, and this is given as 0. M and CV cannot be 0, hence delta T is 0. Delta T is 0, and delta T is 0 means T1 equal to T2. That means there is no change in the temperature, which is a isothermal process. Okay, if we draw this process in TS diagram, if we draw this process in a TS diagram, it will be a straight line because there is no change in the temperature 1 to 2. If we draw this temperature, if we draw this process in PV diagram, it will be like an exponential graph. Because this is a perfect gas, so it follows an ideal equation. So PV is equal to nRT. T is constant, R is constant, N is constant. So this is a constant. So PV is equal to constant, which means they follow a hyperbola curve. Okay, these are some extra points that you should know, that how does this isothermal process looks in the both in TS curve and PV curve. Okay, so from therefore for this question the answer is isothermal process. Now let us go back to the slides. Coming back to the slides, for this question, during a non-flow thermodynamic process 1 to 2 executed by a perfect gas, the heat interaction is equal to the work interaction when the process is isothermal. The answer is option C. For more clarification and reference, you can refer to the NPTEL course Mechanical Engineering Basic Thermodynamics, coordinated by IIT Kharagpur. Thank you.